look at long division. Okay, so this is 5-2A, all about long division. But before we get into the algebra part, I want to refresh our brains of how to divide numbers, right? So way back in elementary school, at some point, you saw something like this, right? You had to divide numbers by hand. Usually it was a 3-digit number and then being divided by a 1-digit number or a 2-digit number. Okay, so most of us these days just get a calculator and type this in, right? But algebraically, it matches up with the way that we divide numbers without a calculator. Okay, that's why I want to use this method. Okay, so it's been a long time since we've seen this, but what you're going to do is draw this little bracket, kind of this little division bar. You're going to put the 6 outside, and you're going to put the 342 inside. Okay, and then we're going to check to see what could I multiply 6 by in order to get 3? Well, there's no integers that are going to make that work, so I'm going to now extend into 34. Okay, what integer could I multiply 6 by to get 34? Well, think about multiples of 6, right? We have 6, 12, 18, 24, 30, and 36, right? And 34 would be in between 30 and 36. So what do I multiply 6 by to get 30? I multiply it by 5, right? And then 5 times 6 would give me 30. So I'll multiply those two and write that number down here, right underneath. And then now I'm going to subtract, okay? 34 minus 30 is going to give me a 4 right here. And I'll repeat the same process. What can I multiply 6 by? What integer can I multiply 6 by to get 4? Well, there are no integers that make that work. So what about bringing this 2 down? How about now? 6 into 42. 42 is a multiple of 6, so I could multiply 6 by 7. I'm going to write 7 up here and then multiply, right? 6 times 7 gives me 42. Now I'll subtract and I get 0 and I'm done. Okay, and then your answer is up here, whatever you ended up writing. So algebraically, that process is going to come back. Okay, so we're going to be able to divide polynomials using long division. Okay, first, let's refresh our brains for how to divide by a monomial. Right, so whenever we see a fraction like this, where we have addition or subtraction happening in the numerator, some variables, and then we have just a single term, a monomial in the bottom, what we're going to do is simplify the numbers and the variables. Do not, this is very important, do not separate addition in the denominator, but we can separate it in the numerator, okay? And all of our exponent rules apply. So we could look at this as if we took 4v cubed and we wrote it over its own denominator, and then minus 18v squared as if we were writing that over its own denominator. And then now we can just simplify each of these as we were doing in the last section, right? 4 divided by 2 would give me 2. V cubed divided by v squared, thinking about your exponent rules, subtract them. 3 minus 2 is 1. So it's going to be v to the first power, and it's going to stay in the numerator because that's where the bigger exponent was. Okay, and then now we see 18 over 2. 18 divided by 2 is 9. V squared over v squared, well, those actually just cancel out, and so we're not left with anything in the denominator, so we could just leave that fraction bar off. All right, and our answer looks a little funny, so I'm going to rewrite it like this, 2v minus 9. Okay. Pause the video, give this one a try. Okay, hopefully you've taken a look at it. You do not have to write it out separately if you don't want to. If you're able to visualize what this would be, that's what I'm going to show you here, then that's fine. If you still need this, though, if you need that step, go for it. Okay. So negative 27 divided by negative 3 is going to give us 9. And then we have an x to the first power and an x to the fifth power. Let's subtract those exponents, right? 5 minus that 1 that's up here. 5 minus 1 is 4. So we'll have x to the fourth power in that denominator because that's where the bigger exponent was to start. Okay, and then z to the fifth over z squared is going to simplify to give us z cubed up top. Okay, and then now we're going to deal with this part, right? 17x to the 6th. So let's take a look at this 17 divided by negative 3. Those can't be simplified, so I'm just going to leave it as 17 over 3 and extend that fraction bar in case we need it. Okay, so x to the 6th over x to the 5th is going to simplify, give us x to the 1st on top. Z to the 5th over z squared is going to simplify and give us z cubed on top. Okay, and that's what you're looking at. If these had the same denominator, we could combine them again, but they're different, so we're just going to leave them separate. Okay, so long division. There's a couple mistakes in these notes. I apologize for that. They'll be fixed. Well, they're printed wrong in some packets and correct in others, so just scribble out this part that says no remainder. Okay, all these are going to have remainders. So our steps, we're going to put the numerator or the expression that is in front of the division symbol, we're going to put that inside. And what I mean by that is when I'm talking about that little division bar, right? So this is inside, this is outside, and then as you're going through the process, your answer is going to show up here, right? The division process. And you'll put the denominator or the expression that comes after the division symbol, you're going to put that outside. If you want to draw this little diagram for yourself, that would probably be helpful. And then ask yourself, what could you multiply by to get the number inside? What could you multiply the outside by to get the number inside? Okay, take a look at this process together. So step 1, we're going to put the numerator or the expression that is in front. Right here, we're going to put that inside. Okay, so draw your division bar first, and then let's put this expression inside. Make sure that you're always writing it in standard form, meaning that your exponents are organized from highest to lowest with your constant on the far right. X squared plus 10x plus 19. Okay, and then we're going to put the expression that comes second, we're going to put that outside. That is step 2, x plus 6. All right, and so let's take a look. We always are going to try to make this first term be multiplied by whatever's up here so that it equals whatever's out front. Okay, so what could we multiply x by to get x squared? We could multiply by x. Okay, x times x gives us x squared. We're going to write that right underneath the term with the same exponent, x squared, and then now we're going to multiply 6 times x as well. Okay, 6 times x gives us a positive 6x. We're going to write that underneath the term that has the same variable or the same exponent, which is x to the 1st power. And then now we're going to subtract. This is where people mess up. Okay, put a big star here for yourselves. That you are going to subtract. Okay, x squared minus x squared is 0. Okay, so we can just not write anything down there. 10x minus 6x gives us 4x. Okay, and we're going to go ahead and always copy down whatever. We're always going to drop down whatever comes here. And then we're going to repeat the process. Okay, so what could we multiply x by to get 4x? Because now 4x is the number that's out front. We can multiply it by 4, positive 4. So we're going to write a 4 up here. Multiply 4 times x to get 4x. Now multiply 4 times 6 to get 24. And then now we are going to subtract. I'm putting parentheses around this so that you remember to subtract both the 4x and the 24. Okay. And so when we do that, 4x minus 4x gives us 0. 19 minus 24 gives us negative 5. Okay. So notice now that the question, what can I multiply x by to give negative 5? Notice how this doesn't have an x with it. All right, the degree, right? This would be kind of like x to the 0 power, whereas this is x to the 1st power. The degree of this number is higher than this degree. That's how we know that we are done. Okay, this is our remainder, that negative 5. Okay, so how we're going to write our answer is like this. All right, your answer is up here, remember? Your answer is up here, so your answer is going to be x plus 4. And then you're going to write your remainder over the outside number, or the outside expression. Okay, so negative 5 plus negative 5 over our outside expression, which is x plus 6. And that is our answer. Okay. I'm going to pick up with some more examples in the next video.